Hey everyone, and welcome back to Brains Are Beautiful. In today's episode, we're going to be talking about exponents, all the properties of them and how to use them in whatever problem you're given. And then we're also going to do a couple examples to show you, how they're used and how they can go away and could be combined. So, I'm going to start with the most simple rule, and that is anything to the 0 power is 1. So that is, let's say we have any number x and it's raised to the 0, that's always going to be 1. No matter what the number is. You could have 8 to the 0, you could have 256 to the 0, and all of this is still going to be 1. It's a pretty awesome rule. Alright, and then the next rule is for multiplication. I'm just going to shorten it with multi. Alright, and this just basically says you can, terms with the same base, you add their exponents. And so let's give an example. So we have 4 to the 3rd times 4 to the 6th. We just simplify this since they have the same base of 4. When we're talking about exponents, let's say we have a to the b. The a is the base, and b is the exponent. Alright, so since we have over here in our example now, we have 4 to the 3rd times 4 to the 6th, and they have the same bases, we can just add the exponents. We can combine these and say 4 to the 3 plus the 6, and that's going to equal 4 to the 9th. Okay, so then if we were to expand this out into general terms, we could just using all variables, we could say x to the a times x to the b, and so this is just saying some number raised to the power a times the same number raised to the power b, and that's going to equal x to the a plus b. So this is exactly what we just did with the 4's raised to the exponents. Alright, so that is your multiplication property. Let's go on to the division property. So if we have quotient of powers, that's the property's name. So quotient. This is going to be where we can divide. So let's say we have 7 raised to the 4th divided by 7 raised to the 2. So there's actually 2 ways to think about this, and they actually go hand in hand. One's quicker than the other, but one's kind of more visual. So I'm going to show you both ways. So the first way, you can literally just write out all the numbers. So 7 to the 4th just means that you're multiplying 7 by itself 4 times. So 7 times 7 times 7 times 7 divided by 7 squared, which is just 7 times 7. You can then just start crossing out terms. So there's that, there's that, and then we're left with 2 7s, which is 7 squared. Okay, the other way to do this is to go 7 to the 4th, which is our numerator, the term on top, and then all you do when you're dividing is you're just going to subtract the exponent. So since we have divided by 7 squared, we're just going to move this squared up and make it negative. So this is going to equal 7 to the 4th minus 2. And that is still going to give us 7 squared. So you can think about this either way. This bottom way is the faster way right here, but they both work. Okay, and then the next property is going to be our power property. And this is the last one we're going to go over before we get to some examples. So this is where we have some number raised to an exponent in parentheses and then raised to another exponent. So let's say we have 6 cubed and then all of that squared. So basically we can just multiply the 3 by the 2, which equals 6 to the 3 times 2, which equals 6 to the 6th. Of course, you can expand this out if you have a calculator, and that gives us 4, 6, 6, 5, 6. And the reason this works is if you actually think of it in terms of the exponent, we're basically, for this term, we're basically saying we want 6 to the 3 times 6 to the 3. And that's why we're given that. All right, so now let's just make this last power property rule in general terms, just so we can use it for whatever numbers we need to use it for. And that's going to be x to the a, all raised to the b, and that's going to be x equals x to the a times b. Okay, and then I wanted to do one more example of this rule just to help you guys out a little bit, because sometimes negatives feel like they get tricky, so let's use some negative exponents in this rule. So one more example, let's say we have, using our pattern here, 10 to the negative 2 and raised to the negative 1. So we're just going to keep following our rule. So we have 10 to the negative 2, and then it says to multiply the exponents together, so times negative 1, and that's just going to be 10 to the negative 2 times negative 1, which is positive 2, which, expanding, we all know that is 100, 10 times 10. Now let's work on some examples. If you've watched my other videos, you'll know that examples are one of my very favorite things as a student to hear that somebody's going to do. So let's do some. Let's start off with, let's say we have negative 5 times 2 squared. So we're just going to start off easy as always, a little easy as always, and then we're just going to work our way into harder and harder examples. So what we want to do is, we know when we have a negative exponent, it has to go on the other sign of the division line. So since right now this is technically saying this is all over 1, we're just going to flip it. And we're going to say 1 all over negative 5 times 2 squared. And now we're just going to go ahead and use our Pemdas rules. Parentheses, exponents, multiplication, division, and then addition, subtraction. And so inside parentheses, we're going to have negative 5 times 2 is negative 10, and that's going to be squared. And then this is going to give us 1 over negative 10 times negative 10, which is 1 over 100. And remember, negative times a negative is a positive. That is how we come out with the positive 100. So that's our first example. And now let's do another example, getting a little bit harder. Okay. Let's say that we have m to the 4th all over 4x cubed, and let's say we have that squared. So now there's several ways we can go ahead and go about doing this, but this is how I'm going to do it. I'm going to break the outside exponent into the numerator and the denominator. So I'm going to say m to the 4th squared all divided by 4x cubed squared. Just basically what you do to the top, you have to do to the bottom, and so we just separated the exponent so it was a little bit easier to look at. So from here, we're just going to use our power rule that we went over, and so this is going to be m to the 4 times 2, which is m to the 8, divided by 4 squared, and x to the 3 times 2, which is 6. So this is basically just distributing the exponent to both parts of the parentheses. And so then just simplifying this out a little bit further, we get m to the 8th divided by 16x to the 6th. That's our answer. And now let's go to one more example. 5a to the 4th b cubed c over 2a squared times the fraction 4a squared divided by b to the 6th c. All right, don't be alarmed. We can do this. So it may look scary, but it's actually going to simplify down quite nicely. So what I like to do when I start this, I want to combine the numbers together, and then I want to get the letters together. And even though it's all multiplication, so they'll all be right next to each other, it just kind of makes it easiest if I put the numbers out front and then the letters behind them. So let's do that. So just like you're multiplying regularly, we're going to go 5. We have a 5 and we have a 4, and we're multiplying them together. So 5 times 4. And on the bottom, our only number is 2. And then we can just write the rest of what we have. A to the 4th, b cubed, c, a squared, and a squared, b to the 6th, and c. So now what I want to do is I want to make them multiply all the numbers together to make it as few numbers as possible, and then I want to combine the different letters together, at least in the same part of the fraction, so that way it's easier to simplify. So 5 times 4 we all know is 20, and we know all we have on the bottom is 2. And then we have an a to the 4th, and we have an a squared. So when we use our multiplication rule that we learned, we have a to the 4th times a squared, which is going to give us a to the 4 plus 2, which is going to give us a to the 6th. So we have a to the 6th, b cubed, c, and then on the bottom we actually don't have anything to combine. We have a squared, b to the 6th, c. All right, let's keep going. So now what we want to do is we want to simplify this. So we want to cancel stuff out, we want to divide, and we want to make this as few terms as possible. So we know that 20 divided by 2 is 10. And now let's get rid of these a's. So we have an a to the 6th, and remember, if we're using our division rule, when we have a to the 6th over a squared, we can bring that bottom exponent up and subtract. A to the 6th minus 2, so that leaves us with a to the 4th. The other way you could have done that was write out 6 a's and 2 a's on the bottom and then start canceling them out. This was a little bit faster. So a to the 6th minus, that's a minus 2, and then we notice these c's cancel out. And then, let's see, we also have a b cubed over b to the 6th. So I like to do with positive exponents. I don't know about you guys. So I'm actually going to, instead of bringing the 6 up to the 3, I'm going to bring the 3 down to the 6. So we're going to have 1 over b to the 6th minus 3. Because we can move our exponents around, just when we bring them to the other side of the division bar, they turn negative. So b to the 6th minus 3 equals 1 over b cubed. So we could put that in here, over b cubed. And when we simplify this down farther, we have 10a to the 4th over b cubed. And that is our answer. And remember, the reason we could cancel the c's out is because they're right above each other. Or you could also think c to the 1st minus 1, when we bring that other c up, that's going to be 0, which we know everything to the 0 equals 1. All right, thanks guys for watching. I hope you learned a lot in this episode. Feel free to rewatch. If you have questions, leave them in the comments below. Exponents can be a tricky idea and concept to wrap your brain around. So spend a little bit of time with it, and I guarantee you will get it. And thanks for watching. And remember, brains are beautiful.